ಹೌದು. ಹಾ. ಸರಿ. ಹಲೋ.
In this, they didn't mention any exam like hello.
Yes,
Any
sir.
separate exam schedule.
Yes, sir.
Any separate schedule is there for exams?
Don't know, sir.
I think they didn't mention anything there. Can you wait 1 minute? I'll confirm now only.
Okay. Okay, sir. Sir, do colleges are opening from February 1? Sir went. Where sir went?
Hello, tell me. Hello.
Sir, February 1st, college is going to reopen, sir.
Yes. Offline classes will be start.
Okay, sir.
Yeah, 1 minute. I'll call to college people. Then I'll ask tomorrow exam is there or not. Then I'll continue the class.
Okay,
Okay.
sir. Okay, sir.
Yeah, maybe it's 15 days once exam it seems. Hello?
Yes, sir.
15 days once exam.
15, what, sir? Sir?
Fifteen days once exam it seems. Hello? Can you able to hear me?
Yes, sir.
Yeah. Tomorrow exam is not there it seems. For
Okay,
first year,
sir.
second year it's there. I think.
Second, sir.
Second years. Your seniors are there. For them is there. For first year not there.
Okay, sir. Okay, sir. Thank you,
Yeah.
sir.
Yeah, yesterday I started second year group element. I completed, I guess. Is it correct? Biological importance of calcium I completed and magnesium I completed. Yes or no? Did I completed? Biological importance of calcium and magnesium did I completed or not? Please let me know. Biological importance. Biological importance of calcium and magnesium. Calcium and magnesium did I completed? Please let me know first. Hello. Hello. Can you able to hear me or not? Can you answer please? Biological importance of calcium and magnesium did I completed or not? Can you able to hear me? Please anyone respond now.
Yes, sir.
Did I completed calcium and magnesium or not? Magnesium, sorry, an adult body contains how much gram magnesium? 25 grams of magnesium and 1200 grams of calcium. 1200 grams of calcium compared with only 50 grams of iron and 0.06 grams of copper. Is it correct? An adult body contains 25 grams of magnesium and 1200 grams of calcium compared with only 50 grams of iron and 0.06 grams of copper. So what are the important biological importance of Mg2 plus? Mg2 plus ions gets concentrated in animal cell. Ions gets concentrated in animal cell. Concentrated in animal cell. And next enzymes involving ATP, adenosine triphosphate requires Mg2 plus. Enzymes involving ATP requires Mg2 plus. Mg2 plus gets concentrated in the animal cell. And third example, this is most important. Mg2 plus ions is constituent of chlorophyll, the green pigment in the plants. Is a constituent of chlorophyll, the green pigment of plants. Green pigment in plants. Is it correct? Is it clear at all? This is the important biological importance of magnesium. Magnesium 2 plus ions gets concentrated in animal cell. Enzymes involving ATP requires Mg2 plus. Mg2 plus ions is the constituent of chlorophyll, the green pigment in the plant. So 25 grams of Mg magnesium and 1200 grams of calcium compared with only 50 grams iron and 0.06 grams of copper. This is the biological importance of magnesium 2 plus. Biological importance of magnesium 2 plus. Please complete. If you have any doubts, you can ask. Once you're done, you can inform to me, please. Is completed. Hello.
Yes, sir.
Next, biological importance of calcium. Can I erase this page? Biological importance of calcium. Please listen. Ca2 plus ion. What are the important biologicals? Importance of biology. Biological importance of Ca2 plus. The daily requirement of calcium in human body about 200 to 300 milligram. Daily, how much amount of calcium 2 plus is required? The daily requirement of calcium in human body is about 200 to 300 milligram. 200 to 300 milligram. Bones and teeth, you know very well, bones is made up of calcium, even teeth is made up of calcium. Bones and teeth contain Ca2 plus ion as apatite. What is the formula? Apatite. Apatite formula is 3 Ca3PO4 taken twice. Ca3PO4 taken twice. Ca3PO4 taken twice. This is called calcium phosphate. Bones and teeth contain Ca2 plus ion as apatite Ca3PO4 taken twice. Next, enamel of teeth. Enamel of teeth contains fluoroapatite. Fluoroapatite, that is 3Ca3PO4 taken twice dot CaF2. This is called fluoroapatite. Animal teeth contains fluoroapatite 3Ca3PO4 taken CaF2. This is called fluoroapatite formula. Animal teeth contains this formula. The next, Ca2 plus ions are necessary to maintain heartbeat. Necessary to maintain heartbeat. Ca2 plus ions are necessary for blood clotting. This is the important uses of calcium 2 plus. The daily requirement of calcium in human body is how much? 200 to 300 milligrams. Bones and teeth is made up of apatite. That's formula is Ca3PO4 taken twice. Animal teeth contains fluoroapatite 3Ca3PO4 taken twice dot CaF2. Ca2 plus ions are necessary for maintain heartbeat. Ca2 plus ions are necessary for blood clotting. So this is the very important biologicals of calcium 2 plus. And even one more important Ca2 plus ion biological importance is there. Can I write the next point?
Yes, sir.
Ca2 plus ions are necessary for muscle contraction. Ca2 plus ions are necessary for muscle contraction. Muscle contraction. So this is the important biological importance of Ca2 plus ion. Next, I am going to uses of alkaline earth metal. Next heading, uses of alkaline earth metals. That uses of alkaline earth metals can say first one beryllium uses. Beryllium. What are the uses of beryllium? Beryllium uses, it is used manufacturing of alloys. Manufacturing of alloys. It is used in manufacturing of alloys. And copper beryllium alloy are used. Copper beryllium alloy is used for high strength spring, to prepare high strength spring. Preparation of high strength spring. To prepare high strength spring, we are going to using beryllium. Metallic beryllium is used for making window X-ray tubes. Window X-ray tube. So this is the important uses of beryllium. Please can I repeat once again this beryllium importance, uses of beryllium.
Yes, sir.
Sure, sir.
Yeah. Here I can say next. Next one. Magnesium important uses. What are the uses of magnesium? Please listen, this is most important. It is used for extraction of boron and silicon. Magnesium is used for extraction of boron and silicon. Is used for preparation of extraction of boron and silicon. And the next one more important, magnesium powder mixed with, please note this point. Magnesium powder mixed with potassium chloride. Magnesium powder mixed with potassium chloride is used in flash bulb photography. This is most important. Magnesium powder mixed with potassium chloride is used for flash and for photography. And next one, magnesium is used for making granulate RNGs is used to making for RNGs. And next one, it is used in preparation of allies. It is used in preparation of allies. This is a preparation of allies. So in that I'm going to take it one by one. This is clearly complete. So what are the important uses of submission is used for extraction of water as magnesium found across potassium chloride is used for flash and for photography. Magnesium is used for making granulate. What is the problem produced compound? It is used for fabrication of many alloys one by one. No one has analyzed this type of water models. Is the most system of water models is water alloys. Is it clear? Is it confirmed? Yeah. Next, what are the important alloys of magnesium? First one, magnesium. Magnesium is important alloy of magnesium. 95% what is the composition for magnesium? 95% aluminium. 5% magnesium with it. Magnesium 95% aluminium and 5% magnesium. It is used for preparation of alloys. Magnesium is used for preparation of alloys. And second one, another alloy that's called electron. Please you need to remember electron means what? Electron is the composition of electron. 95% magnesium plus 0.5% zinc. 4.5%. 4.5% is zinc and 0.5% is copper. So this is the composition of electron. Electron where we are going to use it is used to prepare aircraft. And it is used to construct aircraft. And third alloy, you need to remember duralumin. Duralumin is important material for airship. Duralumin. So what is the composition for duralumin? Duralumin composition 95% aluminum. In duralumin 95% is aluminum plus 0.5% is magnesium plus 0.5% of manganese and 4% of carbon will be there. This is called duralumin composition. Where we are going to using this duralumin, it is used to construct airship, used to construct airship, or it is used to making airship. This is the duralumin uses. And electron magneton. The composition you need to remember, please. Those all are magnesium alloy. And one more is very, very important. This is already told you. A suspension of magnesium hydroxide. A suspension of magnesium hydroxide, MgOH taken twice. A suspension of magnesium hydroxide in water is used as antacid in medicine. Is used as antacid. Antacid in medicine. Antacid in medicine is called milk of magnesia. Suspension of MgOH taken twice is called milk of magnesia. Milk of magnesia. What is that? A suspension of MgOH taken twice. If you complete, you can inform to me. Any doubts is there here? Over. Is it clear?
Yes, sir, completed.
Okay. Next, one more uses. Can you write? Can I erase this page? I'm going to erasing this page. A suspension of MgOH taken twice. MgOH taken twice in water. In water as used as antacid. What is the meaning of antacid? Antacid means in stomach, acid will produce excess amount. To maintain pH level, we are going to taking some antacids like sodium bicarbonate, MgOH taken twice. So that's called antacids to maintain pH level in stomach. So in the body, excess amount of HCl in stomach, excess amount of HCl will produce. So to maintain pH level, we are going to taking that acids that's called antacids. So yeah, MgOH taken twice acting as an antacid. And one more important point, MgOH taken twice is called it. What is that? In water, MgOH taken twice is called milk of magnesia. Magnesia. Milk of magnesia. And next one, MgCO3, magnesium carbonate, is main ingredient in toothpaste. Main ingredient in toothpaste. Please note this point. If you have any doubts, you can ask. Magnesium carbonate is the main ingredient in the toothpaste. Magnesium hydroxide acts as an antacid. which is used to maintain pH level in stomach. That's called suspension of MgOH taken twice is uses. After that, I'm going to next one, very, very important. You need to remember radon. Radon salts. Radon salts is used. Radon salts used in radiotherapy. Radiotherapy. Radon salts are used in radiotherapy for cancer treatment. The treatment of cancer. This is most important. Treatment of cancer. Yeah, this is the important uses of calcium, magnesium, beryllium we discussed. I'm going to next one, 13th group element. Can I start 13th group element? Are important compounds of calcium? Can I complete? Then can I start 13th group element?
Sir, your screen is tilted, sir. Sir, your screen is tilted,
Yeah,
sir.
yeah. Now,
Okay, sir.
Okay, sir.
yeah, can I start important compounds of calcium? What are the important compounds of calcium are there? Please let me explain one by one. First, important compounds of calcium. Important compounds of calcium. Calcium, their first compound CaO is called quicklime. Quicklime or calcium oxide. Calcium oxide or quicklime. Both are same. After quicklime, next one. This is the first important compound of calcium. CaOH taken twice. Calcium hydroxide. Calcium hydroxide or slaked lime. Calcium hydroxide or slaked lime. Slaked lime, otherwise it is called lime water. Lime water. This is the second important compound. Third important compound is calcium carbonate. Calcium carbonate. CaCO3. Marble, limestone, another names of the calcium carbonate. I'll tell you detailing this compound. Next, after that, calcium sulfate we need to remember. Next, calcium chloride. Then fifth one, calcium sulfate. Calcium sulfate CaSO4.2H2. And sixth compound POP, plaster of Paris, CaSO4.2. This is called plaster of Paris.
Sir, once can you define plaster of Paris, sir?
Everything I'll teach, don't worry. Hello?
Okay, sir. Okay, sir.
I'll explain all the compounds.
Okay, sir.
Yeah, next last compound is cement. Seventh compound is cement. Is it clear? What are the compounds we need to explain? CaO, quicklime we need to learn. Calcium hydroxide, slaked lime we need to learn. Calcium carbonate, CaCO3 we need to learn. Preparation, uses we need to learn. Properties. Calcium chloride, calcium sulfate, POP, plaster of Paris, and cement. We need to learn all these compounds. Once you've done, I will start one by one.
Yes, sir, completed.
Good. I'm going to start first one. Quicklime, calcium oxide. I'm going to start calcium oxide. So first compound, calcium oxide. Please listen, this calcium oxide, how to prepare the calcium oxide. Calcium oxide, otherwise it is called quicklime. Please note another name of the Ca. Quicklime. So what is the preparation of quicklime? When calcium carbonate, limestone, all decomposes at 1070 Kelvin temperature. what will happen? CaO will form plus carbon dioxide will form. Only forward reaction takes place in the open vessel. The closed vessel, both forward direction and backward direction will happen. So in the open vessel, what will happen? This carbon dioxide will escape. So the carbon dioxide will escape. That's why in the open vessel, only forward direction reaction is possible. In the closed vessel, what will happen? Reverse reaction also will be possible. That time the carbon dioxide will not escape. So the carbon dioxide mixed with calcium oxide again will form calcium carbonate. Both forward direction and backward direction will form in the closed vessel. In open vessel, only forward direction reaction will happen. So that's why in open vessel, what type of principle is there? Means used in lime kiln principle. What type of principle is there? Lime kiln. Lime kiln principle. This is the industrial preparation of quicklime. CAO preparation. Industrial preparation of quicklime. I hope you people understand in open vessel only forward direction reaction will take place. Why in open vessel carbon dioxide will escape? In closed vessel carbon dioxide will not escape. So that time will form for reverse reaction also will happen. Again will give back to calcium carbonate. Next I'm going to properties. Calcium oxide. So that's why it's called lime kiln principle will be there. What type of principle is the lime kiln? Property CaO mixed with SiO2. CaSiO3 will form. Calcium silicate will form. Calcium silicate. CaO react with SiO2, calcium silicate will form. CaO react with P4O10. CaO react with P4O10, calcium phosphate will form. Ca3PO4 taken twice will form. CaO react with carbon will form calcium carbide. CaC2 will form plus carbon monoxide will form. That CaC2 further react with nitrogen. Calcium carbide further react with nitrogen. CaCN twice will form. 2 will form. Plus carbon will form. CaCN taken 2 plus carbon will form. This is the important properties of calcium oxide. When calcium oxide react with sand, calcium silicates will form. Sand formula SiO2. When calcium oxide react with P4O10, calcium phosphate will form. When calcium oxide react with carbon, calcium carbide plus carbon monoxides will form. Calcium carbide react with nitrogen, calcium CaCN2 plus C will form. So please note this point that carbon is called graphite. After that, you need to balance the equations. To balancing purpose, I am going to write 6CaO plus 2Ca3PO4 taken twice. 2Ca3PO4 taken twice will form. Is it clear?
Completed, sir.
Yeah. Next, please note down. Can I erase this page?
Yes.
Yeah. Please listen. CaCN2 plus carbon. This is called graphite. So this mixture is called nitronium. 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 Nitronium is the fertilizer. fertilizer. Nitrogen is fertilizer. So what are the uses of calcium oxide? Quicklime uses. It is used to manufacturing of. It is used for or used in the manufacturing of. It is used in the manufacturing of sodium carbonate. Of sodium carbonate. Sodium carbonate from caustic soda. Sodium carbonate from caustic soda. So caustic soda means NaOH. Sodium carbonate means Na2CO2. This is the first uses. And second uses, CaO is used for manufacturing of. Used for manufacturing. CaO is used for manufacturing of mortar, glass, and calcium chloride. This three. Mortar, calcium chloride, and glass. This is the uses of calcium oxide. Is it clear how to prepare calcium oxide? Did you understand? When calcium carbonate decomposes at 1070 Kelvin, will give rise to calcium oxide plus carbon dioxide. In open vessel, only forward reaction is happen, and in the closed vessel, both forward direction reaction and backward direction reaction will happen. So in the open vessel, what will happen? Whatever the carbon dioxide will liberated, it will be escape in the atmosphere. That's why only forward direction reaction will form. In closed vessel, that carbon dioxide will not escape. So further that carbon dioxide react with CaO, it gives rise to calcium carbonate. That's called reverse process. Is it clear?
Okay, sir.
Next, calcium hydroxide. Calcium hydroxide means CaOH taken twice. Please listen, CaOH taken twice preparation. CaOH taken twice, slated line preparation. Slated line preparation. How to prepare slated line? CaOH taken twice, calcium hydroxide, otherwise it is called slated line. Calcium hydroxide is prepared when calcium oxide react with water. Will give rise to calcium hydroxide plus H2 gas will form. Not H2 gas, only calcium hydroxide. Calcium hydroxide will form. That is called slated line. So please note this point in aqueous medium of calcium hydroxide. An aqueous medium of calcium hydroxide, CaOH taken twice, is called lime water. Lime water. CaO plus H2O. This is calcium hydroxide in the H2O. This is called lime water. Calcium oxide in aqueous medium is called, what is that? Lime water. Aqueous solution is called lime water. Further, what will happen? Further, carbon dioxide is passed through. CO2, carbon dioxide is passed through. Passed through. Carbon dioxide is passed through lime water. Lime water. and forms calcium carbonate. And forms calcium carbonate, CaCO3 white precipitate. White PPT will form calcium carbonate. Please listen, when calcium hydroxide react with carbon dioxide will give rise to CaCO3 precipitate. This is called, what is that term? Milky precipitate, milky white PPT, milky white PPT. Above milky precipitate further react with excess amount of carbon dioxide, what will happen? Please listen. CaCO3 react with excess amount of carbon dioxide in aqueous medium will give rise to calcium bicarbonate will form. Calcium bicarbonate will form. CaHCO3 taken twice. Calcium byproduct will, calcium bicarbonate will form.
Okay, sir.
Good. Remaining we'll discuss tomorrow. Is it fine?
Thank you, sir.
Thank you. Any doubts is there you can ask, otherwise we'll leave the meeting. Tomorrow I'll start the class. Yes. Can I end the meeting?
Yes, sir.
Yes. Thank you, ma'am.
Thank you, sir.
Yes. Thank you.